So yeah, initially I thought that the talk was 40 minutes, so I thought I wouldn't share the nice things I've seen since I'm here on Friday. Just happened to see it's 50 minutes, so I'll have a bit more time. Before we start, I'd like to ask you a few questions. So first, who's already using Spring Boot? No Spring Boot, using it? Well, most of you. Have you tried Spring Boot 2? Oh, I'm okay. Large chunk. Who doesn't know anything about Spring at all? Nothing. Yeah, there is one person more or less. Okay, more or less, fine. All right, so it's a small audience, so I can tailor the talk a bit. And the next question is going to definitely define that. Who knows about reactive programming? Okay, that's a few. All right, so okay, I'll use a bit of my time to discuss about that. My name is Ste phane Nicoll. I'm working on Spring Boot and Spring Framework. I'm also working on a small site you may have used if you're using Spring Boot, startspring.io. We're not going to showcase that today. But if you don't know about that, head over startspring.io and you can bootstrap your next project very easily. You can also do that from the IDE directly if you want. All three major IDs are supported. So Spring Boot 2, the biggest new feature in Spring Boot 2, so the major release, the first major release since its inception, is the inclusion of Spring Framework 5, and you may have heard a few nice things about it. First is Java 8 Plus now, with support for Java 9, Java 10, Java 11, probably released by the time we exit the room. And the support of reactive programming. And I'm going to spend a bit more time to explain what reactive programming is, since we have like 25% of the audience who knows about it. It's not going to be an introduction to reactive programming, okay? And the remaining of the talk is basically to show you what happens when there is a new choice coming your way. In this case, developing a web application using that paradigm. What does it take for you if you're using Spring Boot? So, do you need to throw away everything you know? Do you have to start from scratch? Or do we offer you a way, basically, to understand and to use those new options? So, reactive programming, what it is? So, it's basically targeted at web applications. You'll understand in a minute why. I just want, before I start, to tell you if you're using Spring MVC or if you're using a regular web application based on the Servlet API, that's perfectly fine. It's not going anywhere. It's still a first-class citizen in Spring, and we will still support it. So it's not about introducing a new way of doing things and then pretending 2 years after that the existing one doesn't exist anymore and then you have to migrate. This is really about a new option. And this is a new option because not all use cases will fit with this new way of doing applications. So I just want to show you a typical use case, and then we will develop, we'll have some live coding, hopefully working, to show you what it takes to implement some of those use cases with Spring Boot. Typical application these days. So let's assume that you, as a developer, you're responsible of the thing in the middle. That's an app. It's doing many things, and it has two types of clients. The first kind is super fast connection, super fast hardware. You want that those users, they get the best experience, right? So if there is something that's happening in the application they need to know about, well, that information is pushed to them. They don't have to refresh, they don't have to ask anything. So you want to make sure that everything that happens in that ecosystem for the application is known right away. If you've done that in the past, you know, so you basically can use a few options there. You can use server-side events, you can use WebSockets, you can use something that you build on your own with some custom JavaScript. But in any case, you know that if you do that, that will consume significant resources on the server. At the same time, nowadays, we have like mobile clients, and a lot of them. And those mobile clients may be on network that do not work reliably. So sometimes it works, sometimes it doesn't. If you try to access something and the network doesn't work, what do? You hit refresh. So as you know, in a traditional model, that's going to issue a new request on the server, a new thread processing the request, while the first one is waiting to timeout because basically that client, so the mobile phone, has requested something again. At the same time, this application is going to access many services, more and more services, because you need to integrate with plenty of other services, and some of those may be slow. So if you combine all of that, this is what happens to your server, right? And there is many reasons why it may happen. Simply because you have too many incoming threads, simply because you have too many sessions to handle on the server, simply because the latency on the remote service is basically killing your performance. So that's one typical use case where you may want to use reactive programming. And you may want to do that not for speed, right? So do not assume that because you're going the reactive way, it's going to be faster. It's not going to be faster, because there's an overhead of dealing with the request. But it's really about if you have lots of users coming your way, and you have plenty of services in the backend that have some weird latency, you're not going to be affected by that. Of course, the request coming from the client, one particular request may be slower, because the backend service at the time is slow, or the network is slow, or whatever reason. But your service will still be able to service requests. Okay? And we will see that concretely in the demo later. Just to put things in perspective from a architecture point of view, this is a regular application, as you probably have built many at that point, with a thread pool model. Usually that's the thread pool of the application server, the servlet container, or whatever you're using. And for each incoming request, a thread from that pool is taken and is processing the full request. Okay? So it's reading the data, it's invoking your business logic, and once whatever the service has to compute is ready, then that thread, the same thread, is going to write data to the client. You know that with that model, you can handle a limited number of concurrent users. You can increase that by increasing the size of the thread pool, but that can't be infinite, since a VM ending a thread takes memory, it takes CPU. So if you want to handle more users, you need to add a server, etc., etc. Pretty basic stuff. If you go the reactive way, it's slightly different, very different even. It could be quite scary at first. At least that's how I felt when I started doing this. A particular request actually is not handled by a thread anymore. And things are not handled in an imperative way either. They are just handled as they come. So as stuff becomes available, so let's say, for instance, if you talking about reading and writing, on socket you use asynchronous I/O and data buffer. So basically, if the network tells you I can read now, because some data is coming in, then you can read. If the network can't read for that particular request, you do something else. Same thing if you've compute something for the user. If the data is ready and you're ready to write, you write. If the network of that mobile client is too slow, you don't write because you can't. So everything is happening asynchronously, and you have a limited number of threads processing the request, right? So these are the things on your right. Basically, that's the number of threads, the number of core that your server has. So the things that you can run natively in parallel, -1. So if you have 16 threads, that would be 15, and there is one thread, which is the thing in the middle, the IO selector thread, which is basically responsible to dispatch actions, dispatch stuff to do. Okay. Of course, as I told you already, that might be a bit scary at first, especially if you don't know about all of it. But there are libraries and there are frameworks that handle most of that for you. And my purpose here in the demo is to show you how, in particular, with Spring Boot, you can implement such application. Right, so we've seen the design, we've seen the use cases, we've seen the architecture. Let's talk a bit about code. This is a non-typical, because there is a huge messy try-catch there. I've put that as a joke. I don't know if it's funny. Usually it is. To show you, well, basically what you would write in an imperative style. So you have a person repository, you have the contract on the right there. That person repository is abstracting access to a store for you and whatever store you might be using. And it may be slow, it may be unresponsive, it may be down. There's many reasons why something will not work the way it's intended, especially when you have lots of concurrent requests. But in this case, the contract is you ask for something and you get the data, right? And if something is not available when you invoke that method, your thread will basically wait. And that's what we want to avoid. Once you have the data, you just invoke some custom logic of yours, which does not involve latency, so it does not connect to the network, or it does not read or write to some file or whatever. It's just business logic, so you just run that. That's CPU handling. And if something goes wrong, you put a try catch and everything works. If you go more with this reactive way of building an application, and as you'll quickly understand, if you want to build an application that way, all your components need to be reactive, right? So all your components need to follow the same logic. You can't have a bit of functional style code like this one, and then after some imperative code that will block, and then after that some more functional style. You need to be, for a given request, you need to be functional, or you need to be neutral to latency and event-based all the way. So you've seen our person repository has changed a bit. Rather than returning a person, it returns some funky wrapper around the person, Mono and Flux. So Mono and Flux are from Project Reactor, which is an implementation of the reactive streams API, reactive streams specification. And reactive streams is a very simple spec. It's only 4 interfaces. And the purpose of the spec is to make sure that various components can talk to each other in a reactive fashion. Okay? So in the spec, you have the notion of so 2 of those 4 interfaces, of a publisher and a subscriber. And the publisher is the thing that can give you data, and the subscriber is the thing that's interested by the data. On that slide, the repository is a publisher because it can push data to you. And you, as a developer, you basically create, or you design, implement a subscriber. So you implement something that's interested by a particular piece of data, and you want to transform it. You want to do something with it and return it to a client, for instance. A little like inside information about those names, which may sound a bit funky, as I've said already. Mono and Flux, especially Flux, may sound funky at first. We spent a lot of time designing those names because we want your code to be as beautiful as it can be. So there were 2 main, let's say, 2 main constraints for us designing those names. One, it should be small, small number of characters, so that doesn't pollute your code too much, your API too much. And 2, they must have the same length so that the code is aligned, right? So we put a lot of effort into that. As you may have noticed from the contract of the repository, 1, which is Mono, is a publisher that returns 0 or 1 element. And Flux is a publisher that returns 0 to n elements. And why is that important? it's important because the reactive streams specification, if you look at the publisher interface, the only thing that you have on it is subscribe. That's the only method you have on it. So you can't do anything. You can't transform the data. You can't map it. You can't transform it. You can't combine it. And that's where an implementation comes into play. In this case, we are using Project Reactor in the case of Spring Boot. So returning mono and flux there basically allows you to transform the data. And one operator you may find, we'll discuss about a few more during the demo, is map. So map basically take a lambda where once the person is available, you can do something with it. So this code above does, I want to find a person with that ID, and once I have that, I want to execute the method called handle. So if we go back to the imperative style, that's basically what you have. And nothing will happen. So this is really, you're basically defining a pipeline. You're basically defining what should happen when the data is in, right? And the last bit, subscribe, which you shouldn't call yourself. In most cases, that's the framework doing that for you. The last bit is actually triggering processing of the data when it's necessary. So Flux and Mono, two implementation of Publisher, the Reactive Streams API. Very important for you to transform and combine the data. We'll see in the demo that there are very powerful stuff that you need to do concurrently, or things that should happen asynchronously. If you're trying to do that in an imperative style, you know that you need to play with thread pool and completable future and callbacks and stuff like that. None of this happens with reactive streams because it's really baked in the core. So it's really a core concept, and you have first-class citizen for it. This is a summary of this very short intro to reactive. So this is what you know, probably. And especially as a Spring user or Spring Boot user, this is what you've been using so far. So the servlet, a servlet container, then the servlet API as an abstraction, and then you have like Tomcat, Undertow, Jetty, whatever application server you may want to use. On top of that, there is a framework to build web application called Spring MVC, you probably know. And there is an annotation model, so typically the thing that you use in your code to define actions, web actions, so controller, request mapping, etc. So with Spring Framework 5 and Spring Boot 2 basically provides the environment for you to develop such application. There is a new option called WebFlux. So WebFlux comes from Flux, determined Project Reactor. Based on an abstraction that we've built, an HTTP-based abstraction using reactive streams that we've built. So that's where you see the different in color, that it's supposed to be green on that thing, but it's not green there, whatever. So the Spring MVC, Spring WebFlux, and HTTP reactive stream is stuff that we've built, and the other one are existing things. So you can see in this new option, the servlet API is no longer a requirement, and one benefit of that is that you can develop and deploy a Spring Boot application on Netty, if you want, or using the native support in Undertow. Spring WebFlux also works with the annotation model, so that's where I'm basically going back to what should you do when there is a new option for you? Should you need to learn everything from scratch? Well, no, because as you'll see in the demo, there's plenty of things that you can still use the same way. And Spring Framework 5 comes also with more advanced functional style programming, and namely a module called WebFlux.fn. WebFlux.fn is an alternative for building web applications using WebFlux that do not involve annotations. So typically, if you want to build a web app only with a programmatic router, so you basically write code where you give all the constraints and which method needs to be invoked when that constraint is met. One of the two applications that we are going to use today uses WebFlux.fn, so you have a chance to see some code with it. So there's a new option in town. There's a new way to build web applications. It's called Spring WebFlux. If you are a Spring Boot 1 user, you upgrade to Spring Boot 2. Then you'd get plenty of new features. You can still, of course, use Spring MVC. But if you want to try for one of your applications that met the use cases I was mentioning earlier, you can give it a try. And that's basically what I'm going to show you today. And we'll work on a smart meter app. So let's assume that we have regions. So you have neighborhood, whatever in a city, like you have an urban neighborhood and a zone with plenty of factories or whatever. And all of these zones have smart meters in each house. And what the smart meter does is, for the sake of the sample here, they publish their power consumption every 10 seconds, right? So you assume you have like, I don't know, thousands of meters per zone, and you have like lots of zones. So you have plenty of meters basically hammering a server, giving its ID, the ID of its zone, the power consumption, and the timestamp. And as I've mentioned earlier, those smart meters may be on data network that are not really fast, or maybe they go down. So you need something that basically handles that load. So they're just sending that data to you. And we have a first app that we call the aggregator. And the first app, the only thing that it does is basically pushing all that data to you in a firehose style. So you get one endpoint with all the data coming from the sensor. We can imagine it's not the case in this scenario. We can imagine that the aggregator stores the data in some store so that you can have a failover or whatever. It's not the case for the purpose of the demo. That really doesn't help the operator on the left because what she wants is to be able to see the power consumption of a zone and see if there are any alerts or any events for a given zone. So what we have is we have a second app called the dashboard, which will connect to that remote service and transform the data. And that's where really Reactor and the operators that Reactor provides comes into play. All right, so let's see a bit of code now. So we have two apps. I'm going to start here. The aggregator and the dashboard. So if we look at the aggregator first, so the thing that consumes data from smart sensor. If you've used Spring Boot in the past, nothing surprising. Well, there's one that's a bit surprising if you haven't used WebFlux yet. You have the Spring Boot starter the usual way, only two. If you've built a web application in the past with Spring Boot, you know that there is Spring Boot Starter Web with Tomcat that allows you to use Spring MVC and the servlet API style way of developing stuff. With Spring Boot 2, there's a new starter called WebFlux, and that one brings Netty by default. Of course, as always, if you prefer to use a different environment, you can override that. And that application is using WebFlux.fn. And rather than using annotations, it defines a router that way. So if you expose a router function as a bean, Spring Boot 2 will detect that and will know that you want to deploy a web application that way. And as you can see, we have two endpoints. We have our firehose, which is here, and that firehose is calling this method. And this method is a regular component, so there is no request mapping annotation because that's what you've put in the router now. Again, the router is very simple at this point. It's really, if you have a get on this, invoke that. But it could be much more complicated. Like you can do content negotiation. You can check if there is a certain parse variable. You can check for request arguments, etc., etc. And the method handle is functional style, so you get a request, you return a response, and you have a new API to basically process the request. So let's see what that firehose does. So these are all the smart meters basically pushing data to you. So if you connect to, so the first app is running on port 8081. So if you go to 8081, I'll show you the URL again. Measures firehose, so that's the portion of the first endpoint of the router, and I'm asking HTTP PI to stream. So I'm basically telling the client that this is something that's going to send me data continuously. Please do not close the connection. Then you'll see that you basically get data from the sensor. So the aggregator actually is generating random data, faking those smart sensor and those zones. Then I have an app. I can go to a zone, a given zone, where I have this graph. And we are mostly going to work on this app and improve it. So let's have a look to it. This app is also using WebFlux, but we've decided to use Tomcat. I mean, it's just a choice. And we use the usual time leaf template, so that's one of the features I want to show you. If you use template engines with WebFlux, it just works the same way as if you use with Spring MVC. And as I've mentioned earlier, if you want to build such an application, you need to be reactive end to end. So if you access a store to persist data, retrieve data, or whatever, you need to do that in a reactive fashion, right? You can't do that imperatively. So that means concretely you need to build a repository that's reactive. I'm going to show you how you can do that. But the implementation of the repository needs to use a reactive-based driver. So that's why you have a reactive-specific starter for the stores that we support at the moment. So we support MongoDB, Redis, Cassandra, and Couchbase. If you're using SQL with MySQL or JPA or whatever, this is a blocking contract per definition. So WebFlux may not be the best fit for that, even though we're working on supporting some of those options. So let's see how that graph was generated, right? So if you look at the graph, you can see that there is 1 point every 10 seconds, right? You can see the timestamp there and the total consumption. If you look at, if I refresh the graph, I get updated data. Of course, I don't want to refresh. That's my point. I want the graph to update itself. So we'll do that in a minute. So the first thing I want to do is I want to store a sample of a sample for a given zone. So what I want to do is I want to store one document per zone and per timestamp. So every 10 seconds, I want to store a document per zone that I'm handling. That document contains the total power. It contains also the number of devices that participated in that total power count. And as you can see, there is nothing funky about it. It's simply a MongoDB document, right? What's a bit more different, and that's where also comes all the other module in the portfolio in Spring Land getting a major upgrade. Spring Data also got a major upgrade with Spring Data K. First major release since its inception in 2009, so there is a bunch of interesting new features in Spring Data. And one of them, of course, is reactive support, because if you want to build an application, you need to have reactive support. If you use Spring Data in the past, you know that you can create a simple interface for your entity, extending from a base interface that will give you a base contract like find all, find one. It's called find by ID now, save, delete, etc., depending on the implementation. So if you want to build a reactive one, you just extend from a reactive flavor, and you can still write your queries exactly the same way, except you do not return the entity or a collection of entities. You return a publisher of, right? Because what you are going to do, you are going to compose those calls. So you're going to say, okay, I want this. When the data becomes available, I want to map that to this. And with the result, I want to call that service. And then I need to compose those data together and returning that data to the client. Pretty much what you do now, except that these are separate calls. In a reactive fashion, you basically define the pipeline. Right, so now I need to, my next move, and that's why this graph works, is because what I want to do is I want to connect to the file host, I want to connect to the remote service. I want to process the data, so basically cut that by timestamp, then accumulate all the meters from that zone and that timestamp, create a document, and then store that document to MongoDB, right? So this is what the sampler does. So this is where you can see the power of Reactor and the operators. So the first thing I want to do is I want to connect to that remote service. So this is this call. And this call uses the new web client in Spring Framework 5. So you can basically guess what that does looking at the code. It's issuing a get on measure file host. And then it's asking that to transform that to a flux of electricity measure. So if you look at electricity measure, there is nothing surprising about it. That's the 4 elements of the JSON document that you've seen, which is still flying by here, by the way. So let's cut that. So the 4 things here are the 4 things here. Easy. So this is going to give me a flux of electricity measure, just like that. There is one extra operator here called share. Remember that because it's going to be quite important in the remainder of the demo. So share, what that does is it's basically transforming that flux into a hot source. What that means is once you have one component subscribing to it, that's going to issue the HTTP call only at that time. Only if something is asking for the data, we will issue the HTTP call to the file host service. And so we're collecting data coming in, as you've seen in the shell there. Let's see now that a second component of my server is also interested by the data and wants to do something else with it. If you share the flux, that new component is going to join the current state of the flow, and it's not going to issue a new HTTP call, right? So by only adding one operator, so only adding the share operator on any flux, you basically get multicast for free. You can join as many times as you want, and as soon as the last one actually cancels or stops subscribing, I'm not interested by that data anymore, that will cut the HTTP connection automatically for you. Right, so by only doing this, I'm getting a flux of electricity measure, but you can see that's not what we have on the left-hand side. That's because the first thing that we do is we window, so we basically split the data into a map of timestamp and of timestamp and meters. So we collect everything from, let's say, 10 seconds ago, blah, 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 blah. We get a list, a flux of those, and then we do something with it. That's the next line. And then once the timestamp trigger changes, we basically get a new map with the values of that timestamp. Once we do that, we will group them. So the next move is you have the timestamp for all the meters of all the zone. What I want is I want a list, or a flux in this case, of the meters per zone and per timestamp. So what I'm doing here is the group by. I'm creating a key, and the key is the timestamp and the zone. And basically all meters that match the key will be collected together. Once I have that, I basically have on the left-hand side my key. So that's the timestamp and the zone. And on the right, I have a flux of meters. So basically, I've processed my data up to a point where I have zone, ID, timestamp, and the list of meters for that zone and that timestamp. And on that, I can reduce, so I can basically loop over those measure and just invoking that method there, which is as simple as it can be. Just adding a new device to the device count and increasing the total power. And I'm creating the document here, by the way, using the value of the key. Once I have that, I basically have one document. I have a flux representing, for each element of the flux, the value, the total power of a zone and a given timestamp. So if you want to see that visually, that's basically 1 point on the graph there. It's one document. So I need to save that, right? So this is a flux of per grid sample. So if I want to save that, I just use the repository and pass that to the repository. And it's going to save that for me. As you would in an imperative style, if you have a collection of elements and you want to save them, well, you pass the collection and the repo will save that for you. The main difference here is, rather than you collecting stuff in memory and then at some point flushing, you don't do any of that. You just have a pipeline. And when elements are coming, they basically automatically are stored in MongoDB without you having to store to do anything of that kind. Remember I told you that nothing happens until you subscribe. So this code will do absolutely nothing because it's just a definition of a flow. It's not actually invoking anything. So in the case of this application, we have a callback interface here. When the Spring Boot application starts, I basically subscribe to my flow. And then that's where I'm starting to connect to the remote service and start saving data. So if you look at the logs there, we should probably have something that says that it starts to log. Starting subscription somewhere. Am I on the dashboard? Yes. So it's not very important, but there you go. So at that point, by the fact that you subscribe, you'll basically issue the HTTP connection. You're interested by that data. The data is coming in. You split the data. You save that to MongoDB. So the next step, of course, to get this nice graph is you need to do something with the data. So let me show you now what the controller does. So the controller does for that zone. So you can find something that you've used in the past, unless you haven't heard from those new annotations in Spring 4.3. That's basically an alias on request mapping. So if you don't know about this, it's the same as request mapping method equal get. So I'm doing get mapping on zone, the ID of the zone, and then what I do is, okay, so give me, history size is 40 by default, give me the last 40 documents for that zone. So that's what the find by zone ID does, and there's a page request here which is the last 40 ordered by timestamp. Then I'm getting some information about the zone. Let's ignore that one for now. Then I map. So again, as you've seen in this on the slide, when you get one data, you get a chance to execute some logic on it. So map, I'm getting the descriptor for the zone, and then I'm basically returning a view. So that's my template here for zone HTML with model attributes, so with information that I'm going to use to render the view, and I'm returning that. And if I'm asking for a zone that does not exist, so switch if empty is an operator you can use if the data that comes is an empty mono, so a mono that completes immediately without data, then I can trigger an error. I can say, hey, that zone does not exist, right? So if I do that with, I know let's put some crap in it, then you'll get an error, and that's my wonderful error page we can find here as well, because there is no mapping for slash. I can use DevTools the usual way. So if I want to have a mapping for home, so rendering is, if you use Spring MVC, it's the same as model and view. So I can do get mapping on slash and selecting a view that's index. This is my view here, nothing funky about that. And that view needs to have an array of zones. So let's add an array of zones, and I have a descriptor here that gives me all the zones. So that's what I want, right? And again, you've seen that I've put a flux in this. I didn't put a collection of, and my page refreshing automatically. I didn't put a collection of elements in my model. I put a flux, and I just let the framework deal for that. Okay? I don't have to deal with this, so it's pretty transparent. So that's the important piece, right? It's a very different way of developing application with many benefits and use cases that are quite narrowed. But on the framework side, we do everything we can to help you, right? So of course, we're not going to ask you to subscribe to the various elements of your model. We're going to do that for you. This is the basic feature. So every template engine works pretty much out of the box with WebFlux because we do that for them. So we subscribe, and once we have the data, so we collect the data, and once we have the data, we call the template engine with the collection, with the actual data that needs to be rendered. So the template engine doesn't even know it's working in a reactive fashion with that mode. You can go further if you use a template engine that has some reactor features, and the ones that they have spent a lot of time on is TimeLeaf with TimeLeaf 3 that you'll get by default with Spring Boot 2. If you use TimeLeaf, that's the version you'll get by default. And they've done two things I won't have time to cover today probably. One is it's a strategy they call progressive rendering. So if you have a huge view that needs a lot of CPU cycle to render because it's very large, rather than taking one CPU to render that huge view and basically prevent other components to use the CPU to do something else. Remember the IO loop? It's basically telling which CPU to do which stuff based on incoming data, right? So if you have something that basically uses the CPU for quite some time, that's perfectly fine because it's no latency, it's actually work. But it might be interesting to render, let's say, 25% of the view and then stop, and let other components process uses the CPU to basically handle other requests. That's what progressive rendering does. It basically renders the view in chunk mode, and you define what those chunks are. So if you have a view that's large, it's a strategy you can put in place to better use your server infrastructure. The other one, which is quite cool, is rendering template fragments. So if you have a view and there's one flux, so one stream of elements basically, that rather than having us subscribe to it, wait for it to be collected as a list and then pass that to the view, to the template engine, you can wrap that in a TimeLeaf specific way. And we will not render, of course, because we will not know. It's embedded in a TimeLeaf object wrapper. But TimeLeaf will subscribe to it. And it will subscribe to it the same way we do. So every time we get an element, rather than collecting all the elements and passing that to the template engine, TimeLeaf can do something when a set of new elements occur. You can say, so that's the data-driven mode, you can say whether it needs to do something for 1 element, 2 elements, 10 elements. So you can basically teach TimeLeaf how much elements it needs to collect before doing something. Spring Data K, I already told you, plenty of nice new features, and I want also to show you something with Tailable Cursor, which I think is pretty cool. So let's get to that immediately. Let's have a look to our endpoint here. I'll show you the code. So if we see the code, you can see that the 40 initial points are basically embedded in the page. So we ask MongoDB, give me the last 40 points. Oh wow, last 40 points for this zone. I'm getting a list. I'm basically embedding the list to the page, and then there is some JavaScript which basically draw the graph. What would be nice is I would like that when there is a new point, I want that pushed to me, right? That's what I want. So what I need to do in this case is I need a new endpoint, and I need a function, I need something on the server that tells me that there is a new document matching my criteria coming in. So let's build that new search method. It also returns a PowerGrid sample, of course, a flux of PowerGrid sample. And I'm going to use a Tailable Cursor. I'm going to tell you in a minute what that is. So first of all, I need to tell the zone, because I'm actually seeing a particular zone. and I want to tell at the timestamp at which we should be looking at, right? What did I do again? Oh yeah, I don't need to implement that. Hopefully that's going to be implemented for me. So Telebur cursor, what that is, that's a feature in MongoDB where you can ask MongoDB to keep the cursor open. So what that does is basically returning a publisher that doesn't close, and when there is a new document matching the criteria, after you invoke the method, it's going to be pushed to you. You see the link I'm getting there? So on one way, I have like the web client being consumed, we transform the data, we save the data in MongoDB, and at the same time, I have another query with an open cursor, and whenever there is a new document matching that, it's pushed to me. And all that happens automatically with only those two definitions. So what I want now is I want to be able to expose, an endpoint that basically pushes that data to the client, to the web client, to the browser. So I'm going to create a new endpoint. I'm going to cheat a bit because I'm a bit low on time. So I'm going to say I want a Power Grid sample, a flux of Power Grid sample. There we go. Stream updates for, something like that. And I'm going to say this is updates, and I'm going to produce service-sent event. So I just want to use a standard mechanism that any, at least recent browser can understand. And I just want to stream JSON right away to the client. Now, let's have a look to this one. It's a bit more, slightly more complicated. So I want that when a new browser tab asks for that zone, I want to open the cursor if it's not open yet, right? So let's say you have like 2,000 operators looking at zone 1. You don't want 2,000 open cursors on MongoDB. That's not going to work very well. So what you want is to check if someone is already connected and has an open cursor. And if there is, just return the cursor that already exists. And we've seen that before. Remember the share operator? We've seen it. Allows you to automatically share any publisher, so a Flux in this case. So that's what I'm doing. And because it's a definition, I need to make sure that I'm returning the same definition, otherwise it's not shared. That's also why, if you look at the electricity measure collector, the definition is actually stored as a field, so that whoever actually asks for that is going to get the same definition. This is the same here. I'm basically collecting those zones. That's the zone ID. That's the definition for the zone ID. And with that, I have, actually that won't work because I need to tell it's going to be a response body. So it's going to, don't use a view, just use the data as the return type. Once I have that, all I need to do is show you my amazing JavaScript skills. So I'm using, again, even source is standard, nothing to do with us. I'm connecting to this endpoint. And whenever I get a new object, I'm basically calling this method which will update the graph for me. So let's see if that works. It better have because I have 2 minutes. Right. Where is my... There you go. Right, so it was updated there, so let me show you this. You need to wait 10 seconds, of course, to update. So this is what we've built in 30 minutes with the introduction. And remember, the thing I want you to remember is if I have 200, 500, 1,000 tabs actually looking at that data, they're going to share, on the server side, they're going to share a single infrastructure. There's only one connection well, that part is is easy because there is MongoDB in the way, so that's pretty easy to share. Actually, I'm going to share the code with you, but there is also an alert mechanism that I won't have time to do today, where if there is some sensor reporting a consumption of 0, and basically have some kind of alert in the browser, and that's actually reusing the Firehose Flux. But here in this case, I'm storing data, and then I have an open cursor per zone, and those open cursor per zone basically broadcast to all my clients. They send server-sent events to all my clients, to all my connected clients. If I close the browser tab now, that's going to close the MongoDB tailable cursor as well, because I'm the only subscriber, so there is no need for that connection to stay open. If I reopen the tab later, it's going to reissue it and basically start where I left off. Okay, so I'm basically 2 minutes behind, so I'm here all day. Feel free to come and chat with me. I can also show you more code in the hallway or whatever. Enjoy the conference. Thank you very much.